Welcome back. Today I'm going to be going over this quadratic function, right, with constants. Um, this type of question shows up on the second module, right, usually on the harder ones, but I don't want to waste any more of your time, so let's get right into it. So before I pursue with the explanation, please give it a try. Alright, so we're given p of x, which is a quadratic function where a and b are constants, and a is a non-zero. P of 2 equals p of 10, and p of 6 equals 5. And it has the x-intercepts are r and s, where s is less than s, or r is less than s. Which choice must be true? So our end goal here is to figure out how many of these choices are true, and like they have to be true, right? So right away, right, we're given a bunch of letters and constants, but let's use the information they give us in the problem to kind of figure our way out, right? First thing they tell us that p of 2 equals p of 10. Now that's actually very useful to know because remember that any quadratic function, right? It has the shape of a parabola, right? Any quadratic function has the shape of a parabola. Now, p of 2 here equals p of 10, right? So let's say this is 2 and this is 10. Again, we don't actually know the exact locations, but this is 2 and 10, and they have the same value at y, right? Because it tells us that the y values at each of these are equal. So because they have the same y value, right, what you'll actually notice is that the center of 2 and 10 will give you like the axis of symmetry for the prop, right? When I refer to that, I mean this line here, right? That goes down the vertex. So this is the vertex here, and it goes down the vertex. So because they tell us that 2 and 10 have the same value, well, if you find the middle of these two, you get the axis of symmetry, right? So to do that, well, we'll just find the average of the x coordinates. So you have 2 plus 10 divided by 2, which gives you 6. So we know that this axis of symmetry is at x equals 6. Why is that important? Two reasons. First, it tells us what the axis is, right? And second, it actually tells us the x coordinate of the vertex here, right? Again, the axis of symmetry always intersects with the vertex of a parabola, right? So this actually tells us the x coordinate of the vertex. And we actually also know the y coordinate of the vertex because it tells us that p of 6 equals 5. So that means the vertex is at 5. Now, why is that useful? Well, any point on the parabola here, right, other than the vertex, it can be reflected across this axis of symmetry, right, and it will end up like on the other side, right? And notice that those points will have the same y value. A special case of that, right, has to do with x-intercepts, right? The x-intercept here, again, this is the x-axis, that's the y-axis. The x-intercept is also reflected across this line and it's going to end up in the same location, right? And we know that the x-intercepts are r and s, right? So we know that this is r and s. Now, similar to what we did earlier, right? We can actually apply the same thing for these x coordinates here, right? You can do r plus s divided by 2 equals 6 because the middle of these two x roots, right, or these x-intercepts are gonna land you in the same location, right, in the middle. It's gonna land you on the axis of symmetry. So we know that the average of those two has to lie on the axis of symmetry, which is x equals 6. Of course, if you solve this, you get r plus s equals 12, because you cross multiply. So our first one is true. Alright, second, we have to figure out if b is positive. How do we do that? Well, keep in mind, what do we know right now? We know the vertex, right, as is at 6 comma 5. So the vertex is at 6 comma 5. And the reason I'm drawing it down is because we know it has to intersect with the x axis here, right? So the only way for the parabola to take shape is if it goes downward. Why is it important that it goes down? Well, because a has to be less than 0, right? Remember any expression of this form, right? Ax squared plus bx plus c, right? If the parabola is facing down, a is always going to be negative. So in this case, a has a negative value. Keep that in mind. That's important, right? That a is a negative number because, right, we can actually use that later on to find whether b is positive. So what else do we know? Well, we know the vertex is at 6 comma 5, right? They give us one form of p of x, right? And they're defining here. We can also write it in the vertex form, right? Because we know the vertex. So we have a x minus 6 squared equals y plus 5. And that's a vertex form. If you don't know what that is, I recommend you look into that, right? But here, right, if you expand this out, you get x squared minus 36x, or sorry, minus 12x. If you put everything on one side, right, distribute these together. So that's what you get when you put everything on one side, just using the vertex form. So now, what you can do is you found another representation of the same equation, right? So you can just set those equal to each other. More specifically, what you can actually do is match the coefficients, right? Since we have to find b of x at some point, look at the coefficient here, b of x, and match it to here, right? Which of these terms here has an x term? Well, only this, right? So the negative 12a equals b, right? Because they both share that x term. So you match those coefficients together, and you get this expression or this equation here. That's actually really useful now because we figured out earlier that a is a negative number. So here you have negative 12 times a, which is a negative number, right? And two negatives obviously make a positive, so b has to be more than 0. It has to be a positive number. So that second statement is true. Lastly, we're trying to find out if the product of the r and s is positive. So to find the product of those two, you have to know what r and s are, right? The values. You can actually find that out. You might be wondering, like, how do you find that out? Well, think about what we know now, right? We know negative 12a equals b. So let's actually plug that back into our original equation they gave us. So we have ax squared minus 12ax minus 6, right? And again, we found negative 12a equals b by matching those coefficients together. So this is actually much easier to work with, right? Because you only see a's. What you can do is plug in what we know, a point that we know. We know p of 6 equals 5. So if you plug in 6 into this, right, you get 5. So you have 5 equals, if you plug in 6 here, you get 36a minus 72a minus 6. You can solve for a here, right? So you get 11 equals negative 36a, and a equals negative 11 over 36. And this is actually really relieving to know that it's a negative number, right? Because we already proved earlier that it has to be negative. So that's how you can like kind of check yourself as you go through the problem, right? So we know a equals negative 11 over 36, right? So let's plug that back in. I'm gonna write this here. So we have negative 11 over 36 x squared, right? Minus 12a, which is 12 times negative 11 over 36, x minus 6, right? So all I'm doing is just plugging in the a value into this expression here, right? This part here, well, that becomes negative 11 over 3, right? You can simplify those, and because there's a negative out here and there's one here, you can make that into a positive, right? So essentially, you're going to have plus 11 over 3. So now, this is actually really useful because we've just found the expression itself, right? We found p of x. And you can use Desmos to replicate this equation, so copy it down here, right? So we have negative 11 over 36 x squared plus 11 over 3 minus 6, right? Now, what you'll notice here is that this parabola is facing downwards, but it has no roots. Oh wait, yeah, I forgot to add x. So here, right, this parabola, again, just to double check, it's facing downwards. It has these two roots. We know that those two roots are just the x-intercepts, right? Those are literally r and s. What's the product of those two? Is it a negative number or a positive number? Well, we have around, you have 10.04, right, or 10.05 for one of the roots, which is a positive, and then our other root is also positive, right? So if you do a positive number times a positive number, well, you get a positive number. So that's why we know that r times s is greater than 0, right? And again, r and s are literally just these points here, right? They are the x-intercepts. So all three of these are true, so our answer choice is D, 1, 2, and 3. Okay, so what should you take away from this problem? Well, whenever you're given these very complex problems, right, the answer is always going to be in the problem itself, right, because you're given this information. So learn to take a piece of information at a time, and as you do that, you're going to find new things about the problem, right? Like, for example, when we did P of 2 equals P of 10, we found the axis of symmetry, right? So by doing that, you'll find new components to the problem, which will help you solve and lead to the other steps of the problem. So I hope this problem makes sense, right? And if it doesn't, again, that's understandable because this is a really hard counseling question. But if you have any questions, leave it down in the comments, and I'll see you next time.